Find all real and imaginary roots of the polynomial equation x cubed plus 2x squared minus 9x minus 18 is equal to 0. So we'll begin by writing down our equation, which is x cubed plus 2x squared minus 9x minus 18 is equal to 0. When we have four terms, one approach to solving the equation is to try to factor by grouping. So that's the approach I'm going to start with here to see if it works. So I'm going to group the first two terms. So that is x cubed plus 2x squared. And I'm going to group the second two terms. That is minus 9x minus 18. And I'll notice between x cubed and plus 2x squared, we have a greatest common factor of x squared. I shall go ahead and factor out. So I have x squared, and then what I have left remaining is x plus 2. I'll take a moment to check this. X squared multiplied by x is x cubed. X squared times 2 is 2x squared. Now I'm going to go ahead and bring the sign down that's in the middle here, which is the subtraction symbol, where I can think that I'm going to factor out a negative from the second two terms. I'm also going to look and see both of these numbers are divisible by 9. So I'm going to go ahead and factor out a 9 or a minus 9. And in doing so, negative 9 times x will give us a negative 9x. Negative 9 multiplied by 2 will give us negative 18, and that's all equal to 0. So now I've factored out the greatest common factor from the first two terms, and I've factored out the greatest common factor from the second two terms. And I'm going to look here and see that I have a binomial of x plus 2. And I'm going to look here and see I also have a common binomial of x plus 2. I'm going to go ahead and write that down, the common binomial of x plus 2. And then I'm going to write down what's left over. This x squared minus 9, and it goes in its own binomial. X squared minus 9. And it doesn't make a difference if I had written x squared minus 9 first, followed by the binomial x plus 2, or in the order that I have it here. So now I'm going to use the zero product rule and set each of these factors equal to 0. That's one approach. I could also continue factoring if I wanted to, x squared minus 9, as it is the difference of two perfect squares. So I'll set x plus 2 is equal to 0. Subtracting 2 from both sides, I'll find that x is equal to negative 2. And this is our first root of the polynomial equation. And then I'll do the same for x squared minus 9. I'll come up here. So we have x squared minus 9 is equal to 0. And I'm going to solve this using the square root property. So I'm going to isolate the x squared in this case by adding 9 to both sides of the equation. So I have x squared is equal to 9, square rooting both sides. These are inverse operations. So square rooting the square, I'll be left with x on the left side. When I introduce that square root, I'm going to put a plus or minus here. So we have x is equal to plus or minus the square root of 9. And the square root of 9 is 3. So we have x is equal to plus or minus the square root of 3. So the roots to this polynomial equation are negative 2 plus or minus 3. So we have 3 roots here. Negative 2, positive 3, as well as negative 3. And so we have found all real and imaginary roots to the polynomial equation given.